All right, well, welcome to day 20. We're going to be reviewing for the first part of our next test, which will be next class period. You're going to need out your calculator, something to write with, and a separate sheet of paper. The sub will also be passing out a sheet of graph paper, which will be used later on at the very end of the period when we do one where we sketch a velocity graph, position graph, and go from there. Now on the first part of this test, there will be one question that is very similar to part 1 of our test from day 15. So be sure as part of your studying to look through that test because there'll be one that is very similar to that. So now let's get started, the second half of this unit. The main new thing that we saw is that someone could start ahead. Now, if someone's starting ahead, that means they're starting a certain number of meters ahead. You cannot tell that from the velocity graph alone. This must be told in the question. And the first time we actually use that information, like if they told us they started 2 meters ahead, is in the T-chart. So the T-chart is the first time it is used. So that is the main thing we learn in the second half of this unit. So that's definitely going to be on the test somewhere, okay? Because that's the biggest new thing. So on the separate sheet of paper, we're first going to look at describing the motion based on some position graphs. So we haven't done these for a while. They weren't on our first test of the unit, so it's something we still need to look at. So these are position and time graphs. As you're describing them, feel free to use your position amount as meters, your time as seconds. And we want to know where you're starting, the direction you're moving, if it is away or toward. We want to know, is the speed increasing, decreasing, or constant? And if it is not possible, we would want to know why it's not possible. Now, our two main scenarios we saw of why it's not possible would be if you can't teleport or if you can't be in two places at once. So we're going to pause the video and give you about 6 minutes or so to see if you can write your descriptions for all three of these. Again, you want to talk about where they start. For each part, the direction of movement. Is the speed increasing, decreasing, or constant? And if it's not possible, just tell why it can't be possible. So again, we'll give you 6 minutes to try these three. All right, first one, we're starting at the detector, or you could say start at 0 meters. Move away at a constant speed. Stand still for a bit. And then move away at a slower constant speed. Constant speed because our slope is constant during that time. Second one is not possible because you can't teleport. And third one, we should be starting at the detector. Our slope is getting steeper, so we move away at an increasing speed. And then the slope starts to flatten out, so we slow down, but we're still moving away. And then that last part where it gets steep again, we speed back up. All right, here's two more for you to do. Again, position and time graphs, number 4 and 5. Doing these on your separate sheet of regular paper, not on the graph paper. And same thing, see if you can describe it just like we did in the last ones. And we'll pause the video for, we'll say 4 minutes for you to do these two. So for number 4, we should start at the detector, walk away at a constant speed, then stand still for a bit, and walk away at a faster constant speed, stand still, then walk toward at a constant speed. Number 5, We're going to start at the detector. We're going to walk away at an increasing speed and then slow down while you're still walking away. All right, we'll look at two last ones of these. So we'll call these 6 and 7. So again, do these on your separate sheet of paper. And we'll, again, pause for 4 minutes to give you a chance to do these two. Remember to tell where you start, direction, if speed is increasing or decreasing, and if not possible, tell why. So the first one is not possible because you can't be in two places at one time. So like at this time here, this is saying we're at both of those locations at that time, which is not possible. And in the last one, we're starting at the detector, move away at a decreasing speed because our slope is getting smaller. Then we turn around and we walk back toward, and as we're walking toward, our slope is increasing, so that is at an increasing speed. All right, next one. Let's say rumba goes the same velocity as tango for the same amount of time. We want to know, do they finish at the same position? So we're going to pause the video for 2 minutes for you to talk about this with someone nearby. So again, rumba and tango, they're going to go the same velocity for the same amount of time, and do they end up at the same position? So hopefully we said no, and the reason is basically the new thing we've seen the second half of this unit. Both characters are not necessarily starting at a position of 0. One could be starting ahead. Okay, so do they finish at the same position? No. One could have started ahead. So that's the big new thing the second half of this unit. So keep that in mind as you're doing the test. Characters don't necessarily have to start at 0, 0 anymore. They could start ahead. Now that would have to be told in the question. Velocity graph can't tell us that information at all. And the first time we would use that information that they're starting ahead is when we go to make the t-chart. All right, now we're going to go to the graph paper that the sub has passed out to you. If you need more at any point, there's a big stack up on the front table. So we've got Tango takes 3 seconds to get to his top velocity of 3 meters per second. He stays there for 3 more seconds. Rumba takes 3 seconds to get to 2 meters per second and stays there for 3 more seconds. Rumba is going to start 4 meters ahead. And a couple things we want to do. We want you to draw a velocity graph for this scenario. Make sure to label who's Rumba, who's Tango. Then do your t-chart and your position graph. Again, making sure to label who's who. And then we want to know who finishes ahead and by how much. So we're going to give you about 10 minutes to do this. Okay, so we're going to pause the video on your graph paper, do your velocity graph, do your t-chart and your position graph, and then answer who finishes ahead and by how much. All right, Tango takes 3 seconds to get to 3 meters per second and then stays there for 3 more seconds. So your velocity graph for Tango should have looked like that. Rumba takes 3 seconds to get to 2 meters per second and then stays there for 3 more seconds. So here's Rumba's. So that's your velocity graph. They told us that Rumba started 4 ahead. So in our t-chart, Rumba should be at 4, Tango should be at 0. So let's do Tango first. Tango had 3 triangles at the beginning with bases of 1, 2, and 3. Tango's sloped line goes up 3 and over 3. 3 divided by 3 is 1. So we have y equals 1x for tangle slanted line. Sub in a base of 1, you get a height of 1. Sub in a base of 2 for x, you get a height of 2. Sub in a base of 3, you get a height of 3. So now do your areas of the triangle. 1 times 1 is 1, divided by 2 is 0.5. 2 times 2 is 4, divided by 2 is 2. 3 times 3 is 9, divided by 2 is 4.5. When you're doing those triangles at the beginning, they include the previous triangles, so you're not adding them on. And then each second for tango after that is a 1 by 3 rectangle. So we're adding on 3 more, so we have 7.5, 10.5, and 13.5. For rumba, also 3 triangles with bases of 1, 2, and 3. So he goes up to and over 3, so that's y equals 2/3 x. When you sub in 1, you get 2/3. When you sub in 2, you get 4/3. When you sub in 3, you get 2. 1 times 2/3 divided by 2 should give you 1/3. But we had already started at 4, so that should be 4 and 1/3. So we're tacking it on to the original. 2 times 4/3 divided by 2 is 4/3. Well, 4/3 is the same as 1 and 1/3. Tack that onto the 4, so we should get 5 and 1/3. And then 2 times 3 is 6, divided by 2 is 3. Tack that onto the 4 that we started with, and he's at 7. Well, now each rectangle for rumba is 1 by 2, so we're adding on 2 each time. So we'll have 9, 11, and then 13. On our position graph, it looks like should be able to scale it by 1s. There's our tango. It's curved at the beginning because he was speeding up, and then straight after that. And I switched colors, I just realized there, but that's our tango graph. And then our rumba graph, we're starting at 4, then we got 4 1/3, 5 1/3, then we got 7, 9, 11, and 13. So notice tango does catch up to rumba. So who finishes ahead? Tango finishes ahead. And by how much? By 0.5 meters. So on next class's portion of the test, you'll see a lot of things similar to that. Make sure to look over part 1 of our test from before on day 15 that had the 4 problems on it. You're going to see one question really similar to that in addition to the types of things that we saw today. Only homework is to study and have a great rest of your day.